So I will be introducing CPI equation. So first you might wonder, what is CPI equation? CPI equation is the average number of cycle per instruction to execute a program. But why we use CPI equation? So basically, CPI equation act as a performance matrix to evaluate the performance of processor. For designer, they use CPI to analyze the trade-off in the design of instruction set, processor pipelines, and also memory system organization. So how CPI equation used in evaluation? So basically, every processor target to get a CPI equals to 1, which means high performance. Since CPI equals to 1 means that each instruction only require one clock cycle to execute. So basically, you can see there's an equation to calculate CPI. So it's calculated by summing up the product of percentage of occurrence of the instruction category times with the cycle per instruction for that category and divide it by the total instruction count. We're able to obtain a CPI for that particular processor. So in example, we have to calculate the CPI for the processor that we design. So basically, we can see there's three types of instruction, which is loads and LU operation and also stores instruction. So by summing up all the product of percentage and clock cycle for each category, and we divide it by hundreds of total instruction count, we obtain a 1.85 CPI, which doesn't shows high performance, but it is sufficiently for daily use.
For the Park-Amdam law, so what is the Amdam law? Amdam law is a formula which used to calculate the expected system improvement under a fixed workload when the system is improved, and is usually used to apply to calculate the speed up of the parallel computing. For the formula, the speed up formula is the as time to execute program on an parallel processor divided by time to execute program on a single processor. For our processor CTW86, we are able to obtain the time taken for a single core and 8 core in exporting a video in Premiere Pro, which is 380 seconds and 137 seconds. So after applying a speed up formula, we gain the speed up achieved 2.77 when the core is used for the processor increase from core 1 to core 8. However, there is a from the unknown law, there is a limitation of speed up of the system, which some tasks can only execute by the sequencers. So the speed up from one core to 8 core doesn't is 8 and only 2.77. However, our processor is also achieve a top ranking on the same level processor.
In summary, features of this processor is middle performance and handle daily work of students and officials. The CPI equation is one of the analysis data to support evaluation processor. Operation looks ALU operations and stores to be used to calculate CPI. It showed that neither 1.85 cycles per instruction to execute a program. Calculation of AMDA loss to be used for calculate speed up. So time to execute program on 8 parallel processor divided by time to execute a program on a single processor to calculate the speed up. Performance speed up of this processor is 2.77 seconds. Therefore, this evaluation certifies this processor performance.